Hi, Ms. Byrne. For my quarter 4 portfolio, I'm going to do a project on simplifying radicals. A radical, to put it simply, is just that. People automatically look at this and refer it to the square root symbol. And that's exactly what it looks like. Now let's warm up a little bit. See, people that have been in math class and have done math throughout their life probably knows what this would be. You see the square root symbol and they see the number. Now, automatically, people are like, oh, 6 times 6 equals 36. 6 is the square root of 36. Wow, that's easy. Well, that's a tricky thing with radicals. It's not always going to be perfect. Now, the numbers that are perfect square roots is like 2 to 4, 4 to 16, 5 to 25, 6 to 36, 7 to 49, 8 to 64, 9 to 81, and so on and so forth. But not every single number can be that perfect. Now, here's an example. 50. Now, you might think that this looks easy. Well, it kind of is once you understand it. Now, to solve problems that don't have a perfect square root that easily, you have to factor it. So we learned these little tree branches from Miss Byrne, from you, and I think from Miss Stevens in 8th grade. And so you find two numbers that go into 50. Now, let's do 25 and 2. You think you're done? No. 25 and 2, that's good, because I found the largest factor of 50, but it has a perfect square root. And so, we just make that 5. Because 5 is a square, 25. 5 is a square root of 25. And so, 5. And we bring the 2 down, and we just bring the 2 right there. Now, someone looking at this that doesn't know radicals that easily would be like, hey, Franklin, why don't you use just 5 and 10? Well, that'd be tricky, because 10 doesn't have a square root, and 5 doesn't either. So I found the largest possible factor that has a perfect square root. That makes the problem that much simpler. Okay. Let's do another problem, but let's change it up. Okay, not going to erase all that. Let's do square root of 72. Now, there are many different ways to figure out radicals and solve them. But, you know, once you find a way that works for you, that your teacher teaches you and you're comfortable with, you can start using that. So 72, we're gonna use a different way to solve it than what you taught us, Miss Martin. Now we know that the square root of 36 is 6. 6 times 6 is 36. Now 72. What number times 2 goes into 72? 36. So the square root of 72 would just physically look like this. Correct? That's 100% true, because 36 times 2 is 72. So this is actually 100% equal to that. This could even equal something even a little bit more complicated. But if you want to get down to it, it'd equal 36 times 2 to the half power. Because that technically is what the square root is, the half power. So that's if you want to get really technical with it. That's the same as raising each of the numbers to the half power and multiplying. Okay? So we understand this to this, and we understand how this equals this. Now, that is also 100% correct, what I have written right here. This is to go even more in depth. That's to the half power. Okay? And so, that's like saying times square root of 2. And we already know the square root of 36 is 6. And so, all this work would be brought down to 6 times the square root of 2. And that's actually the answer. So this and this, boom, you found your answer. Now, let's go in a little bit more in depth. What happens if you have a question like, what is 7 times the square root of 27? We can rewrite this to equal something simpler. 7 times, wow, okay, that's a multiplication symbol. 7 times 9 times 3. The reason I use 9, oh god, the reason I use 9, remember, is because it has a perfect square root. And so, that technically is the same thing as this. 7 times square root of 9 times 3. Based on the rules I just showed you, this can translate to 7 times 9 times 3. Now, since the square root of 9 is 3, our problem written down so far is 7 times 3 times the square root of 3. So 7 times 27, you do this out, 7 times 3 equals 21, radical 3. And that's our answer. Now, as you go into bigger numbers, the technique you use is still the same. Alright, let's try 252. Now, this would be equal to, once you do everything out, 2 times 2 times 3 times 3 times 7. You have to do a little bit of work in this, but it's 2 times 2 times 3 times 3 times 7 to equal 252. That's what you have. Now, what are we going to do with these numbers? We now determine the index of the radical. So you take these numbers and push them out. You need 2 of a kind, and so you just bring the 2 and the 3 out. So what you come up with is 2 times 3, 7, which translates to 6 radical 7. And that's your answer. See? It's easy once you do a couple problems with it. Thank you for watching this, Ms. Burton. I hope you learned more about radicals.